Seriously, man, this is ridiculous. How can you get this much entertainment out of a Q-tip? It's clean, don't worry. I mean, he enjoys them, so I give him clean ones. And now she's just watching them. Oh, I think she's gonna pounce. But wait a second here. Freaked him out. She's just waiting. She is just waiting. Get him. Get the man. All right, that's enough of that. Okay, we're moving on to the final page. You're wondering, this is what I do when I'm not in school, is I just talk to them. Okay, we got some circle problems on the back here. So, and we're going to be using something we haven't done in a little while as well. So, PQ is tangent to circle C at P. If PQ equals 5, CQ equals 6. PQ equals 5, CQ equals 6. And let's see, if it's tangent, we know that this is a right angle. Something I've gone over a little bit. So we've got a nice right triangle. We're looking for the measure of angle C in this case. So what you're going to have to do is use a little inverse sine, something we haven't done in a little while. All right, sine of that degree is going to be equal to 5 over 6, opposite over hypotenuse. So if the inverse sine then of 5 over 6 should give us our degree measure. So the measure of angle C, 56.4 degrees. Okay, now in circle H, the measure of angle, or measure of arc, DR equals 40 degrees. And the measure of GOR is 210. So that looks like 40 right here. This is 210. One thing I would do first on this, let's get the last arc, so GD right here. This is going to be 110 degrees. Just do 360 minus 210 minus 40. That'll get you that 110, that last little part. And so to find the measure of angle RGO, all right, that's what we're being asked. RGO, I want this little one. What my goal is going to be is to find out what this arc right here is measured. Because if we just take half of that, of arc RO, we'll get our angle that we're looking for, that inscribed angle. So one thing I'm noticing is if we add the measure of arc GD to the measure of arc DR and the measure of arc RO, those three things together, 1, 2, 3, then we'll get 180 degrees. All right, we've got ourselves a diameter coming through here. So that would mean, since this is 110, this is 40, there's only 30 more degrees to be had. So the arc RO should be 30 degrees, just 100 minus 110 minus 40. And so that means that the measure of angle RGO would have to be 15 degrees. Right, just taking half that inscribed angle. Now, AC is a diameter of circle E. Area of a circle is 289 pi units squared, and AB equals 16 units. All right, so that's a lot of information. So that's 16. The diameter is, or AC's diameter. What else do we know? We know that the area is 289 pi. I guess we don't know much else. So I'd like to know, I guess I'd like to know this length, and we could figure that out. Since we know that our area is 289 pi units, area is found by pi r squared. That'll help us find the radius, which then will help us find the diameter. These pi's are going to cancel out. I could divide both sides by pi. So r squared is 289. You should know this off the top of your head by now. Radius is 17. Square root of 89 is 17. So 17 AE is 34. All right, double that radius gets you the diameter. And let's see, we're looking for BC first. Okay, so BC, that's what we're finding right now. You could do Pythagorean theorem. I think that's probably the best course of action here. So BC squared plus 16 squared equals 34 squared. This is a right triangle in here. How do I know that's a right triangle, you may ask? Well, this is a diameter, meaning that the inscribed angle attached to it has to be 90 degrees. It's half of that 180. All right, thought you might have had me there. Not quite. Subtract 16 squared from both sides. You're going to get BC squared equals 900. And BC will then be 30 after you take the square root of both sides. It's one of ours, so this is 30. And now we're looking for the measure of arc BC. Okay, so arc BC, that's this arc right here. I think what we should do here, if we can find the measure of, again, if we can find the measure of angle A, since that's the one that attaches, that's the inscribed angle that sort of attaches to it. If we double it, we'll get our arc measurement that we want. So this is equal to sine, another inverse sine problem. All right, sine of that would be 30 divided by 34 opposite over hypotenuse. Now the measure of angle A, you'll find that to be 61.9 degrees if you put that into your calculator. So, since this is the inscribed angle, just double that. And the measure of arc BC is 123.8 degrees. Well, that was a doozy of a problem, wasn't it? Last one of number 12. Triangle ABC is inscribed in the circle below. Using the measurements provided, find the measure of angle or arc AB. Interesting triangle we've got here this time. Since this is 112, this arc right here, I'm going to look at where it ends, bring it back. I've got an inscribed angle, which means it has to be half of the arc, which makes that 66 degrees. Got a triangle right here, so if you do 180 minus those two, you should get 49 degrees, just that 180 in a triangle. And now I want this arc, it's across from that 49 degree angle. Let's do 49 times 2, gets you a 98 degree arc. All right, last problem. Number 13, finding the missing variables. So KL and MP intersect. We've had a problem kind of like this before. If KL is 8 inches, we've got 2 of that already, so I need 6 more inches to make that 8. Same idea, multiply the 2 parts of the chord. 2 times 6 equals 3 times x. So 12 equals 3x, x has to be 4. And easy peasy if you know what you're doing. Let's see, what's our relationship here? We've got a central angle and an inscribed angle. So that means, and this is I guess a little tricky to set up, but if I multiplied this by 2, I would get the central angle. So 2 times x plus 4 gives me that central angle. So 3x minus 9 equals 2x plus 8. Do you distribute that? I'm going to subtract 2x, add 9, so x is 17. Awesome. Let's see, onto this one. So we know 52, so inscribed angle, the arc is going to be double that, so 104 degrees. I've got 131, I've got 104. Let's take that 360 minus 131 minus 104, and that's going to give us what x is. This ends up being 125 degrees. Awesome. Almost here, almost done. So now we're finding x, y, and z. And so we've got ourselves a little right triangle. If this is 78 degrees, then this has to be 12, right? It's 90 plus 78 plus 12 is 180. And these are all across from one of those angles. Each are x, y, and z are all across from an inscribed angle. So it's going to be double the inscribed angle that it's across from. You can see that this is coming up quite a bit here on this last page, that inscribed angle idea, how it's double, or it's half of the arc that it's across from. So x is across from 90. That makes it, all right, let's just lay this out first. Y is across from 78 and z is across from 12. Just multiply each one by 2. So 180 degrees. This would be 156 degrees, and this would be 12 times 2, 36 degrees. All done. Okay, let's see. Central angle. Got an x and a y again here. Central angle is the same as the arc that it's across from, so that would make that 114 degrees right across from it. It may not look like it, but y is actually the inscribed angle, or one of the inscribed angles for x and for that arc, right? They end at those 2 points. So y is going to be that 114 divided by 2, which is 67 degrees. I don't know why I bother boxing those. They're already in a box, but we're already doing it. Oh, easy one. Both of these are a radius of the circle. Radii of a circle are all the same length, so these two must be equal to each other. Subtract 3m, subtract 1, 2m. It's going to be equal to 8. Divide that by 2. M should be 4. All right, that about concludes review guide number 3, I guess it was, for Chapter 10B test. Hope you're nice and prepared. Again, I would maybe watch this a couple times, maybe go through, fill things in the first time, then go back, see if you can make sense of each of the problems. If you do that, you should be in great shape for the test. All right, we'll see you next time.